All right, welcome back for another deep dive. Today, we're going to be talking about an article you sent in. It's about China getting ready to launch their own space telescope. The headline had me hooked right away. China is building a space telescope to rival the JWST, and it could survive in orbit decades longer. Decades. That's unheard of. So we're going to be diving into all the details about the CSST, or the China Space Station Telescope, and why it has the potential to rewrite the textbooks, not just today, but for years to come.
Yeah, it's not just rewriting textbooks. It's like we're launching a time capsule of scientific discovery. We're putting this incredible piece of technology up there, knowing that we can constantly upgrade and adapt it as new tech emerges. Who knows what mysteries we'll be able to solve decades down the line that we can't even fathom today.
That's honestly kind of mind-blowing. It's like setting a course for the future of space exploration. But let's start with the basics. What exactly is this CSST?
Well, the CSST, which also goes by the super cool name, Unjinin, meaning surveying the sky, is China's answer to the James Webb Space Telescope. It's their flagship observatory, set to launch as early as 2026, and get this. It's designed to have a field of view at least 300 times greater than the Hubble Space Telescope.
Wait, hold on. 300 times greater than Hubble. But how does that even work? Isn't the CSST's mirror smaller than Hubble's?
That's the beauty of it. It's not just about size, it's about how they're using cutting-edge optics. Think of it like swapping a regular camera lens for a wide-angle lens. You're getting a much bigger picture without sacrificing the details.
Okay, so we've got a wider view. But what exactly is it looking at? The article mentioned something about near-infrared light.
Right. Seeing in near-infrared is key. It lets us peer through cosmic dust clouds, which block visible light. It's like having X-ray vision for space. Think about it. The early universe is shrouded in this dust. So near-infrared lets us see back in time to those very first galaxies, those baby pictures of the universe.
That's wow. So we're not just looking across vast distances, we're looking back in time. I hadn't thought of it that way. The article also mentioned a bunch of other powerful telescopes coming online. Are they all working together?
There's a whole new generation of these cosmic detectives coming online. One that comes to mind is the Nancy Grace Roman Space Telescope being developed by NASA now. While the CSST is all about breadth, getting those wide-angle shots of the universe, the Roman telescope is designed for extreme depth. It's going to zoom in on very specific tiny patches of sky with incredible detail.
So it's like having different tools in a toolbox. The CSST is the wide lens capturing the whole scene, and the Roman telescope is the magnifying glass, zeroing in on the tiniest clues.
Exactly. And when you combine those perspectives, the insights you can gain are just phenomenal. That's where the real magic happens, when different telescopes with different strengths collaborate to paint a complete picture of the universe.
That actually makes the whole rivalry with the JWST that an article mentioned seem a bit overblown.
I think it's more about national pride than true competition. At the end of the day, science wins when we work together. The JWST has its own strengths, and the CSST will bring something totally new to the table.
So what are some of the big mysteries these telescopes are teaming up to solve? You mentioned this time capsule concept. What kind of questions are we hoping to answer, maybe even decades from now?
Well, one of the biggest ones is dark matter. We know it's out there, making up a huge chunk of the universe, but we have no idea what it is. The CSST is going to help us map its distribution in ways we've never been able to before.
And what might that tell us?
Imagine we find out that dark matter doesn't clunk together like normal matter. It behaves in ways that defy our current laws of physics. That would be a complete game changer, forcing us to rethink everything we thought we knew about the universe.
Okay. Yeah, I see how that would rewrite the textbooks. I'm starting to get why you called it a time capsule. We might not even have the right questions yet for the data it's going to collect. Is there anything else the CSST is going after?
Oh, there's so much more. Dark energy, the force that seems to be accelerating the expansion of the universe, is another big one. The CSST will be able to make incredibly precise measurements of this expansion, which could finally give us clues about what dark energy is and where it comes from. And that's just the tip of the iceberg.
I can't wait to see what they discover. But let's talk about how it's going to do all this. What makes the CSST different from other space telescopes?
Well, remember how we talked about the CSST being like a time capsule? It's not just about the advanced technology it's launching with, but about its potential for growth. Unlike most space telescopes, the CSST will share an orbit with China's Tiangong space station.
Honestly, I hadn't even thought about the implications of that. So it's not just up there on its own. Does that mean we could, service it, send astronauts to fix it or something?
That's exactly it. Think of it like having a pit crew in space. Astronauts can actually go out and perform repairs, swap out instrument modules, even potentially upgrade the telescope with entirely new tech as it becomes available.
That changes everything. Most telescopes, like Hubble, have a limited lifespan. Because, well, it's hard to fix something that's millions of miles away. But with the CSST, we could be looking at decades of operation. Wouldn't that make it even more powerful than the JWST, at least eventually?
You're getting it. The JWST is amazing now. But technology moves fast. Imagine the CSST in 20 years, outfitted with instruments we haven't even dreamed up yet. It's like the gift that keeps on giving to science.
This is giving me chills. It's like we're launching a telescope that's going to evolve with us, constantly pushing the boundaries of what we can observe. What kind of cosmic events could we witness with that kind of longevity?
Well, imagine being able to capture not just one, but a whole series of supernovae explosions in a distant galaxy, or maybe even witness the merging of black holes, those cosmic titans warping the fabric of space-time. These are events that happen over incredibly long timescales, and having a telescope up there for decades increases our chances of observing them dramatically.
It's like having a front row seat to the universe's greatest show. But wouldn't constant upgrades make it hard to compare data over time? How do scientists make sure their measurements are consistent if the telescope itself is always changing?
That's a great question. It's a challenge, but scientists are incredibly meticulous about calibrating their instruments and accounting for any changes. They develop complex models and algorithms to ensure that the data they collect remains accurate and comparable, even as the telescope evolves.
So it's not just about throwing new tech at the problem, it's about making sure we can interpret the data in a meaningful way. That makes sense. So with all of this in mind, what are you most excited about? What's the thing that really gets you pumped about the CSST?
For me, it's the possibility of discovering something truly unexpected, something that completely throws us for a loop and forces us to rethink our entire understanding of the universe. With decades of observations, constantly refining our view with new technology. Who knows what we might find? Maybe we'll uncover an entirely new type of celestial object, or even evidence of something beyond our current comprehension.
That's what I love about space exploration. It's the ultimate mystery. There's always something new to discover, something that challenges our assumptions and expands our knowledge. This CSST feels like it's going to be a huge part of that for a long time.
It really makes you wonder what kind of textbooks they'll be writing 50 years from now based on the data the CSST collects. It's like we're giving future generations this incredible tool to explore the universe in ways we can only dream of.
And they'll probably look back at us and our current understanding of the universe and think, wow, they had no idea.
Exactly. It's a humbling reminder that we're always learning, always pushing the boundaries of knowledge. And who knows, maybe some of those future discoveries will come from kids who are listening to this right now, inspired by the possibilities of the CSST.
Okay, I'm going to need a minute to process that thought. That's pretty inspiring. But before I get lost in existential wonder, let's bring it back to the CSST. What are the key takeaways here?
Well, I think the biggest one is that China's CSST is going to be a major force in space exploration and cosmological research. It's going to be up there for decades, potentially changing our understanding of everything, from dark matter and dark energy to the evolution of galaxies and the birth of stars.
And it's not just about the technology itself, but about the potential for collaboration and international cooperation. It's about scientists from all over the world working together to unlock the secrets of the universe.
Absolutely. This isn't just a win for China. It's a win for science and humanity as a whole. And I think that's worth getting excited about.
I couldn't agree more so. For all of you space enthusiasts out there, keep your eyes peeled for news about the CSST in the coming years. It's going to be a wild ride. And who knows, maybe one of you listening will be the one to make that next groundbreaking discovery using the data collected by this incredible telescope. Decades from now. That's it for this deep dive. Thanks for listening.